Okay, next we will look at the chemistry of frying. So what is deep frying? Deep frying is when the food is heated by immersion of the food inside hot oil, and it would involve usage of oil in high quantity. Okay, because the food need to be totally immersed inside the oil. And for deep frying, the temperature are rather high, in the range of 160 to 195 degrees Celsius. At lower temperature, frying would take longer, especially when it involves less amount of oil. However, to fasten the frying process, then deep frying is the solution. However, this deep frying would leads to the deterioration of the oil itself, due to several chemical reaction. So deep frying is actually a complex process involving both the oil that is used itself and the food that is to be fried in the oil. This figure shows the chemical reactions occurring during deep frying of food. Okay, so we take example of potato chips here. Okay, immersed in oil. So what happened during the deep frying of these potato chips? Okay, first of all, we look at aeration. So aeration will occur where the oxygen will be incorporated. Okay, oxygen in the air in the surrounding will be incorporated into the oil, which will lead to oxidation. So I have covered that what happened during lipid oxidation in the presence of oxygen is formation of hydroperoxide. Besides hydroperoxides, conjugated dienes will also form, and these are unstable and converted into secondary products, which are alcohol, ketones, as well as aldehyde, which in turn then converted into the tertiary compounds, which are free fatty acids and also hydrocarbon. Now, the hydroperoxide can also undergo can lead to formation of dimer, trimers, epoxide, as well as alcohol and hydrocarbon. Because the peroxide formation here will lead to formation of hydroxyl compounds. Another reaction that occurs is absorption of oil onto the food, okay, during the deep frying process. Next reaction is vaporization. Vaporization occur where it leads to the release of volatile compounds, okay, from the reaction from the oil also. Okay, steam also released, especially if the food are frozen, because frozen food have water content also. So in the presence of steam, it will lead to hydrolysis reaction. So hydrolysis reaction is the broken down of the triglycerides of oil into free fatty acid and glycerol. Okay, so the free fatty acids can be monoacylglycerol or diacylglycerol. Now, besides these chemical reactions here, polymerization can also occur. Polymerization will lead to the increase in terms of the viscosity of the oil, especially if the oil is used repeatedly or prolonged use of the oil, and also leads to forming of the oil when it's repeatedly used. Okay, so this is the hydrolysis reaction. Okay, the breaking down of the triglycerides. Okay, so you have triglyceride in the presence of water will break the triglyceride into the glycerol and also the free fatty acids. Okay, so steam, like I mentioned just now, okay, given off during frying, which remove volatile antioxidants, free fatty acids, and also other volatile compounds. Now, contact with the air will lead to auto-oxidation, okay, now lipid oxidation, and this will form large number of degradation product. Okay, and then the steam will result in hydrolysis, which will form free fatty acids and the partial glycerides. So this table shows oil absorption. Okay, one of the chemical reaction that can occur is the absorption of oil by the food that is being fried. So if you see here, potato chips and corn chips will absorb high percentage of oil, okay, compared to donuts or french fries or other frozen food. Now imagine if the oil is used repeatedly, okay, so the repeated usage of oil will lead to the formation of these undesirable compounds, which is unhealthy for us to consume, but then it's being absorbed by the food and then you consume it. So that is why it is not recommended to use the oil repeatedly, maximum probably around twice, then you just discard the oil. Okay, from there you can see when oil is repeatedly used, the color would also change. Okay, means the oil darken in color, so that is an indicator that of the formation of compound, okay, as well as mallet browning also occurring. Okay, so this is polymerization reaction. Okay, it's actually a reaction that is converting or isomerization of the cis compound into trans compound. Okay, so the suitability of oil for frying also related to the content of the unsaturated fatty acid of the oil, especially linolenic acid. And this has been described as inherent stability. So it's calculated based on the level of the unsaturated fatty acids, which are oleic, linoleic, and linolenic, and their relative reaction rate with oxygen. Remember, when there are more double bond present, it's it would be uh, thermally and oxidatively unstable. So this is the value of relative rates of different fatty acid with oxygen, referring to the fatty acid content in oil. So compared to oleic acid, which only has one double bond, linolenic with three double bond will be very much reactive with oxygen. So therefore, high reactivity with oxygen will lead to lipid oxidation, which is undesirable in food. But thermal degradation of oil containing linolenic acid will actually provide a better aroma during the deep frying compared to if we use hydrogenated oil or fats. But then prolonged use of oil containing this unsaturated fatty acids will produce volatile compounds, which are shown in the figure previously. These volatile compounds normally gives off flavor to the food that is being fried. Okay, so the higher the inherent stability, the less suitable the oil is for frying. So inherent stability relates the relative reaction rate of the unsaturated fatty acid with oxygen. So therefore, it is best to choose oil with low inherent stability for frying purpose, because it's less susceptible to oxidation. So these are the different values of inherent stability of different oil. So you see here, soya bean has the highest inherent stability, and if you read up, you know that the agenda of a country that says that these kind of oil are very good, are healthy by right. It's actually not, because they are the mass producer of this kind of oil, and they actually look down on palm oil, which is in fact better still to be used for frying because of the low inherent stability. Okay. So the best is of course coconut oil, but it's not economically to be produced for frying purpose. So palm oil is considered good already, okay, for frying purpose. So the high inherent stability of oil here are not suitable for deep frying purpose.